right, here we go. Network cabling and media. So, I mentioned earlier, a lot of people think of routers and switches whenever you think of networks, and I've been doing this for over 20 years now, so I start thinking of all the little details whenever I think of networks. Not just routers and switches, but just the crazy amount of devices that we have now on networks. And I'm talking about the components too, right? Different types of connectors and cables and frequencies and you name it, okay? But let's get going to make sure we understand the basics and we've got those down. So, what media do we use on a LAN? Well, it depends on the type of LAN we have, but everything nowadays is typically a unshielded twisted pair cable. Now, it could be Cat5, it could be Cat5e, it could be Cat6, it could be Cat7. There's all different types of categories of cabling. What the categories typically depend on is the amount of resistance it has for interference from crosstalk and other type of EMI around the cabling. So the higher the grade, the better quality the cable, and also the faster data that can be sent down that cable. So, for example, Cat5 cable is only rated at 100 meg connections. You need a Cat5e to even start thinking about gigabit connectivity. So, building wiring does matter for sure. These are the most common type of Ethernet cables out there, and of course, this is just a patch cable. We call it a patch cable because it's got both ends that are pre-terminated. We run this all throughout buildings and in walls and everything, and cablers come down and they punch them down on a female jack and also in the patch panel. And there's a couple different ways to do the pins, and we'll talk about that in a minute. You might also have some coaxial running around. Now, a lot of this is today used for kind of the last mile of TV and or cable modem connections and things like that. But coax has been around for forever, and it was really big for TV communication, things like that. But like I said, nowadays it could be the last mile, what we call the last mile or the last leg of the network to your place business or whatever. So it's kind of interesting. For a long time, students used to ask me, why did cable modems take over DSL? What happened to DSL? Well, we started learning how to multiplex data across different types of medium a long time ago, right? And the telephone companies saw the explosion of modems. The first modem I had was like 9K, man. I mean, it was rocking and rolling. That would take you basically 100 years to download just one of the Katy Perry YouTube videos out there nowadays. But anyway, it was like 9K. And then they went, 14 baud, and then 24 baud, and then 48, and then 56, 64, all that kind of good stuff. So they saw this rise and this explosion in the demand for, internet connectivity as the internet exploded, right? Well, the DSL companies had all this copper twisted pair cabling. Now, it was not 4-pair like the Cat5 or Cat6 cabling you see there. This was just plain old 2-pair, okay, or single pair of cabling for phone lines in houses. And they were thinking, how can we multiplex data and get more data out of that, circuit than what's offered by these standard modems, okay? And so we started doing this multiplexing, and you can do time division multiplexing, frequency division multiplexing. There's all different types of multiplexing we could do. But long story short is the underlying medium that we were using to send more data, even though it was good for 6, 7, 8, 10 megs at certain spots, it was still based on a very weak foundational cable, okay, which was just a pair of copper wires. Now, then the cable companies are out there and they're like, man, in order to do television services, we've had to run fiber to all over the city. Even if we ran coax in your house, right, to get to your television set, outside somewhere there's a utility pole that has, a big junction box for the area, and to get to there to supply cable to all you guys, we've had to spend a ton of money building and trenching fiber, okay? Now, fiber can sustain a tremendous amount more data than the traditional copper pairs, and it has to do with interference and distance and energy over distance and stuff like that. Light can be used to travel much further and faster. Bottom line is the cable companies realized I can send more data across our existing fiber cables with multiplexing than I can than the telephone companies can. And unfortunately, the telephone companies weren't out there trenching a lot more fiber to keep up with it, right? So, but yeah, anyway, that was another tangent, and you learned something new, hopefully. But so yeah, coaxial cabling is the kind of that last leg stuff that may come into the house nowadays. We typically don't use this that much, though, for internet connectivity, unless it is coming to a cable modem from the cable companies, based on what I just told you. All right, and then we've got fiber, and we have all different types of fiber, guys. The main couple modes of fiber that we have nowadays that you might see used is multi-mode fiber and single-mode fiber. Okay, multi-mode fiber is what I would use in a building to connect switches and or different floors of a building together, things like that. Single-mode fiber is what I would use to connect outdoor buildings, each building to each other. So multi-mode within a building, single mode to connect very long distances, right? And there's a couple properties why I would do that. We'll talk about it for a bit. And then finally, another type of media that has blown up like no tomorrow. I'm so lucky to have the career I've had, and a lot of it is thanks to Wi-Fi, 802.11 based Wi-Fi, and really any type of wireless technology in general. But RF, radio frequencies, man, we can easily modulate data and send data over airwaves, which is really freaking cool. So the predominant media we use is a specific channel, okay? And we have certain channels that are allotted that we can use, or certain bands, radio bands that we can use, and the 2.4 gigahertz industrial, scientific, and medical bands in the US. And we also have some 5 gigahertz industrial, scientific, and medical channels. And then we have a lot more 5 gigahertz channels that are allocated to us in the what's called uni bands, which are the unlicensed national information infrastructure bands. Bottom line is they're non-licensed bands that we can use to send data across radio waves. And so we can just buy the equipment, and we can use any of the channels within these bands or bonded channels within these bands, and they're unlicensed. So we can scale these networks very, very large, and we're going to do a whole section on Wi-Fi in a little bit, but very cool stuff. Wi-Fi can expand, can go throughout the campus, and it could be a LAN, a MAN, a WAN, all that kind of stuff, or WLAN, WMAN, WAN. It's what my wife used to call me, was a WMAN, wireless man. Yeah, anyway. So UTP cable, again, is by far the most widely used data cabling in the world. And, we might see the patch cables, or you might be familiar with these patch cables to patch things in. However, like I said, it's ran inside the buildings, and cable installers come in and they'll pull hundreds of cables through conduit throughout the building, and then they patch them down in patch panels. Okay, and so this is the backbone of networks, is how the cables interconnect everything. Yeah, we have these devices that connect and interconnect data, but we're relying on some type of underlying media to get it there, right, and to share the data. So the cable installers will install all the cabling, and then we can bring our network devices like our switches in and stack them up in the switch cabinet. Okay, and these are typically referred to as MDFs and IDFs. We'll go over that later. And then we use these patch cables to patch everything in. So these cables come back to each of the ports you see in your rooms, on the walls, in your cubicles, wherever they're at. These jacks that we plug in the patch cables to are connected to that wiring that runs throughout the building, right? And so the cabling company is the one who comes in and does all this portion of it, and then it allows us simple cables to just connect our laptop or desktop or whatever number of devices there is. I mean, there so many different types of devices are on the network now, even light bulbs. Most of it's Wi-Fi, but they're doing like lighting controls and stuff with Ethernet, which is pretty cool. And Wi-Fi is being used for ungodly amounts of things. So again, these are some of the other standards. Cat5e is where we can start getting gigabit throughputs, and Cat6 we can get from the 3 to potentially 10 gig. Cat6a is really where the support comes in for 10 gig. All right, so as part of a Network Foundations course, it just would not be complete unless we showed you the cabling pins and colors for properly cabling devices. Now, the most common type of cable out there, if we're connecting from our device to another type of device, like from a client or a PC or a laptop to a switch, would be a straight through cable. So straight through cable, the traditional coloring for that is white, green, green, white, orange, blue, white, blue, orange, white, brown, brown. Okay? Now, with that said, and then both sides would be pinned the same way. So both ends of the cables would have the same pairs on a straight through cable. It's straight through. So the same cable ends are going to be there on both sides of that cable. Now, if we need to connect similar devices, okay, and we'll go over this in a second, like two PCs together, we would need to do a crossover ourselves, okay? Switches and our building cabling standards allows us to do the crossover through the infrastructure, right, through the cabling that's there in the building and the patch panels and all that. So if we got to connect similar devices with a cable we made, then we need to do it with a crossover cable, like two routers directly to each other without a switch, that type of thing. Okay, so this is the standard type of cabling to do a crossover. So you would cross over one end of the cable, you would use this way. The other end of the cable, you want to convert the transmit and receive ends. So you notice this is RX, RX, TX. This is TX, TX, RX, and then RX where there's a TX. And that way, two hosts can talk and talk to each other, right? Talk and talk back, I guess. So we use crossover cables sometimes, but most of the time it's straight through cables. That's the predominant form of cabling out there. And again, understand what type of cabling you're using for the building codes. Bottom line, as far as color coding, because some people are like, if I'm making cables, do I really care that I'm using white, green, green, white, orange, blue, white, blue, orange, white, brown, brown? Or can I just make them the same on both ends? And the answer to that is you can actually just make sure the same colors are on both ends of the cable. And it'll work as a straight through cable. You could use whatever combination you want to, as long as the tip and ring sides of the cables are crossed the way they need to. But remember, these standards make it easy to understand what's going on. And if somebody else were to pick up the cable, they'd be like, what the hell is this cable doing? And they might not look at both ends to see, oh, well, they just made a straight through cable, or oh, they just did a weird kind of color combination on a crossover cable. So it is best to kind of stick to the standards. And I know it can be a little bit more tedious sometimes. You're just like, I'm just going to make this match and I'm good to go. But it's best to stick to the standards, especially if you're doing a commercial project or a professional job and you're not just jacking around at home. Definitely stick to the standards. All right, so that was UTP cabling. Now let's talk about some other cables that are very common. Console cables, okay? So I remember, man, 96, 97, I got my first serial cable, my first serial console cable. Actually, probably a little bit before then. But this was my first Cisco router cable, man, and I felt privileged. These things have been around forever. They come with every Cisco switch and every Cisco router. So chances are you have a stock room that's filled with these if your company uses Cisco. Now, other network vendors might use their own proprietary kind of serial cabling, but this is a serial cable. Okay, now it's blue in color, and you see one end has that serial port on it. And the other one is got a standard like RJ45 that goes in the device itself on the serial port to manage that device. Now the newer devices that are coming out, they also have a Bluetooth option, and Cisco sells these new Bluetooth cables, by the way. These are on all the newer devices that are out there, and they even started making this little adapter to do Bluetooth console cabling, which is pretty cool. Now, here's the problem with this old cable and why they started doing the USB. And you know, USB, it's tricky because a lot of people want to use like MacBooks, and they're not even putting in traditional USB ports in MacBooks anymore. They're getting so freaking thin that it's like the Lightning ports only or USB 3. So then it's like, which type of USB cable do I need to get? And it gets confusing. Yeah. So it's yeah. I stick with the classic. I have one of these in pretty much my backpack at all times, just because you just never know. If you're going to start working in networking, you want to get a couple of these. Make sure you got a good rig with one of yours. And then this is another device nowadays that you must have, because chances are your computer doesn't actually have a serial port on it anymore. Yeah, this uses serial communication, and we quit putting those in computers a long time ago because they take up so much freaking space. And they're legacy. We just didn't use them for anything other than connecting to old network devices that didn't need a lot of data to go through it. Now, a word on these USB to serial converters. Standardize as a company on which ones you're going to use, because the drivers for this stuff can be ridiculous, especially with Windows 7 and Windows 8. The drivers can be just an unbelievable, painful problem, even in Windows 10 sometimes, because these are made, very cheaply sometimes, and they sometimes come with like a mini mini CD-ROM. Nobody's even got a CD-ROM in their laptops anymore. At least I don't. I haven't had one in the last 3 laptops I've had. So make sure you get the drivers for it. You know it works on your operating system, and you've got a good USB to serial conversion or some type of setup where you can use your serial cable, because if you work in networking, you can manage all your network devices once they're up and running via the network. However, to get them up and running and to get them their addressing and make them reachable and do the setup and everything, it all starts with this stuff. This is one of the predominant ways of doing it. Now, if you're a major enterprise, you might be like, oh, well, we're using auto configuration and auto deployment and this and that and the other. That's great. But if you're in this class and you're just, you're learning the foundations, you need to get this set up. Okay, so get you a USB to serial adapter. Read the reviews on Amazon. Make sure it freaking works like it's supposed to. You can see if you have USB ports on your computer to get a Cisco USB console cable. I have both because I picked them up. I hardly use the USB one, but anyway, use whatever you feel is comfortable for you, right? But you will need this to manage the network devices. And then this will also, if you do other devices that aren't Cisco and they have different pinouts and stuff, you might also get another type of adapter that lets you change the pinouts. I know it seems silly if you haven't had to do this, but believe me, the last thing you want is to have to do some type of repair on a device and you need to change 2 freaking pins in the serial communication to have that device give you a terminal session, and you can't do that because the device is fixed. So get ready to get ready to do some fun, I don't want to say soldering, but there's some little kits where they allow you to easily change the pins, and or you can make a cable and just change the pins with cable. You can do it that way too. So get ready to do some fun stuff like that if you have non-Cisco devices that are out there that you might need to support. Alright, so what cables do we use to cable the network? Okay, well, for the exams for the Cisco CCNA and for the CompTIA Network Plus exams, those type of exams, and probably for the A Plus exam, there's probably several that have to do with all this, but you're going to use crossover cables for similar devices, and I've already said that. Okay, so crossover cable for similar devices, straight through cables for dissimilar devices. So PC to switch, straight through cable's fine. PC to router, straight through cable's fine. Switch to router, straight through cable's fine. But if I go switch to switch, the old correct answer is I use crossover cable. Router to router, correct answer is I use crossover cable. When I say that's kind of tricky, I don't want to say tricky, but things have changed. So switches for at least a decade have had a feature, especially Cisco switches, that's the ones I've predominantly worked with, have had this feature called auto MDX. And this auto MDX feature allows the switch on a port-by-port basis to detect if the cable is straight through or not, and then automatically change the service to support whether it's straight through or crossover. So in the newer switches, it doesn't really matter if I use a crossover cable or not, because the switch can recognize and change the transmission to adapt to the cable. But for the exam's sake, anytime I connect similar devices, I use a crossover cable. Anytime I connect dissimilar devices, I use a straight through cable. All right, so with fiber can really help us out with things, okay? It helps us communicate at the speeds of today. And even if you don't have fiber at your particular company, if you're any sizable company, I bet you do somewhere. Because once we start talking multi-gigs and 10 gig and 40 gig and 100 gig and all that kind of new stuff, the terror stuff, man, you're using fiber, okay? It allows data and a lot more data to pass through the medium than copper wires, okay? Because the other stuff, the UTP cables, is unshielded twisted pair copper cables, okay? Now, even though I can do, in clients, we've been using that standard for a long time, and for computers and access points and all the other kind of network devices, Cat 6, 7 is going to be there for at least a while. We're seeing more than anything the number of wireless devices actually explode as far as clients, though. Laptops and desktops, there's a lot of people moving to all wireless office that's using nothing but Wi-Fi for desktops even, but especially for laptops, because you want that mobility. You want to be able to move around the office. We don't want to be stuck in a cubicle all day, right? But fiber is that backbone high-speed connection that allows all that data to move at the kind of the pace of business. All right, so there's different connector types, and it depends on the type of device that I have, which connector type I'm going to be using, and also which type I'm going to integrate with. So let's say a service provider is handing me off a new 10 gig fiber network, and I'm going, yippee, man, this is awesome. Well, they may hand us any one of these types of connectors here, and then I'm going to need to be able to integrate with that in my device. So I need to make sure I have a port that can support that type of connector, right? So there's many different types of connectors out there. The most common forever was that ST and SC, but that's quickly been replaced and kind of updated to the LC and stuff. I mean, honestly, I see it all. I see the MU. I mean, see all this stuff really. The ESCON and the MTRJ is probably the least common that I'm seeing out there, but yeah, we see this all. And the thing is that these typically plug into what's called an SFP, which is a little module. So the switches are modular nowadays. So instead of having an integrated port that would take this type of connection, you buy a little module that has the ends on it like you need, okay? And then you put that module in the switch port where you want to support that uplink. So these modules have actually started becoming more and more like prefabricated cables on both sides, and you just plug in the cable to both sides, right? And you've basically got switches that are just nothing but SFP ports. I'm kind of jumping ahead a little bit, but anyway, these are different type of connectors, and there's a transmit and a receive side on fiber pair. So it's always going to be a pair of cables. It's always going to be one transmit, one receive, okay, at a minimum. All right, so we have multimode fiber that can give us gigabit speeds at up to 600 meters. So that's pretty good ways. Single mode fiber can give us 10 gig speeds and now even more than this, but 10 gig speeds at 10 kilometers. Okay, 32,000 feet. So get us out there a ways. And that's just a patch cable, right? I mean, that's just a cable. So as you add in repeaters and extenders and all that, we can go really, really a long ways with fiber for sure. Yeah, there are service provider fiber runs that provide petabyte speeds, which are, yeah, I would love to have that kind of bandwidth. Couldn't do anything with it necessarily because the computing power you need to take advantage of it would just be insane. But, you know, hey, we'll still love to have it, right? Better to have and not need than need and not have. That's what I say. All right, so let's cable the network. Based off the cabling mechanisms that you've seen, let me add one more here. Let's bring that down a little bit. Hang on one second. So, I bet it's real hard to figure out what type of connection medium that's going to be, right? All right, so we need to go 100 feet from switch to switch. What type of cable would we need there? Sorry, I drew the there over there for the AP. So what type of cable would we need for 100 feet? Well, 100 feet, going from switch to switch, we've got some options, okay? Going to an end station, that's very easy. We know that's a straight through line. So we're going to use our cat cabling for that. Depending on the speeds, not GAT. I'm going to use my GAT. No. Cat UTP cabling for that. So we could be using like cat. I did it again. All right. So we'll say cat 5 or cat 6, whichever one I need depending on speed, if I'm doing gig or 10 gig. Now, we've got this jagged line over here that's going to this station that's an administrator. He's going to do some managing of this device. So what kind of cable do we need there? So if you were to say that we needed this serial cable here, you would be right, which is what we would need here to manage this device as well. Now, what about this cable here, switch to switch? Remember, on the exam, if you say it's 100 feet and you say that we need a cable there, that could be Ethernet Cat 5 or 6, because that can easily do 100 feet. Cat 5 and 6 cable actually can go up to 100 meters, which is 328 feet. Okay? But did you remember to do a crossover cable? That's the tricky part about that one. That one's going to be a crossover cable. Even though some of the new switches have that feature, okay, you still want to, similar devices, crossover cable. Now, for the next one, to get from this switch over here to this router, we've got 500 feet that need to get between it. So while this could be our Cat 5 or 6, we've got 500 feet right here. Remember that Ethernet cabling, UTP cabling, can only go up to 100 meters, 328 feet. So what would we use? We could use fiber here. So that's going to be a good fiber connection. Okay. Multi-mode or single mode at that distance would be fine. Now, single mode would probably be excessive. If it's just 500 feet, you could do multi-mode easy. So now we've got this cabling to the AP that's going to be our traditional UTP cabling, whatever speed we're doing. Now, what if I've got a gigabit AP and I'm using a 100 meg cable? There'd be a bottleneck. So I need the right type of cable there for that. So I would use a Cat 6 cable here, whatever it is, Cat 6A. And then obviously we're going to use RF here, okay, between the AP and the client. And that could be a 5 gigahertz channel, it could be a 2.4 gigahertz channel, but that would be radio frequencies that's giving us that 50 meter connection. Which, by the way, we haven't started the Wi-Fi module yet, but the radio frequency portion can actually tip from a typical AP that's also 100 meters of coverage as well, okay, that it could support up to. The reason I took it down a little bit is because with Wi-Fi we use an adaptable bandwidth selection, okay? So the further out we are from the service, the lower data rate we would have, which means I didn't want to just show and say, oh, you could just throw APN and do 100 meter connectivity. You could. It's under the right conditions, because there's also things to worry about with Wi-Fi like interference, and we'll talk about that in the wireless section. Long story short, we can, a typical AP can cover up to 100 meters, but I was just kind of giving you the example with 50 there, so you'd still have a decent data rate. All right, so that is the data cabling portion and RF cabling, and that's how we interconnect the different devices on our network. Just some examples, right? But we'll be talking about more as we go through the network, and I hope you enjoyed the section. We'll see you in a sec.